So we are working with an institute in Thailand, which is called NARIT, and that's the National Astronomical Research Institute of Thailand. And they are developing astronomical instrumentation and are participating in space project with the Thai Space Consortium.
Because right now we are working on very challenging space projects, which right now in Thailand, NARIT, we still lack a lot of knowledge to reach the challenge. So we try to learn something very cutting-edge technology from our partner in UK.
They are designing their own satellite, which will be an Earth observation equipped with a high perspectral imager, which will actually look at the ground and look at specific chemical fissures on the ground to try to get science information.
We're in a position of immense amount of knowledge and experience that's been built up over years, decades, even for some of the people here. And we're working with institutions that have the same goals, and we've got some excellent departments and academics. But there's just sort of a bit of a gap, and that's the sort of the gap that we're looking to fill, and then all of a sudden all of their ambitions in the related fields can start to come to fruition.
So the technology is called single point diamond turning, and it's using a synthetic diamond to cut the metal. You know, the diamond is the hardest material that you can find, and with that material, when it's polished, it can cut metal. So here we are cutting aluminium or brass to make a specific mirror with a shape which is very specific for the application.
We use it to produce the mirrored surface for the telescope, in this case being like a space telescope.
What we do is we take points across the surface, and we do that to generate a 3D version of the part, and from that we can take the data of the sizes, the tolerances. We can also create a point cloud, which allows us to ensure that the free-form surface is correct to our technical drawings.
Ultimately, knowledge should be shared. So in this particular project, we've been kind of helping our Thai colleagues kind of upskill and kind of learn some of the techniques that we very much take for granted now, whereas they very much reliant on the kind of their neighbouring countries to support them, so it kind of enables them to get some independence.
So the project is funded by UKRI, STFC and the Newton Fund, and it involves 3 leading UK universities. So Durham University is the leading institution, and we work with University of Sheffield and the UKATC in Edinburgh.
My role is to support the additive manufacture design. So within the programme there's a conventional design, which is created by mill, drill, lathe, but there's also a kind of, let's say, less conventional design, which is additive manufacture. So it's looking at how we can use additive manufacture, which is essentially 3D printing, so creating a structure layer by layer, and how we can use that manufacturing method to create metal components that have a new type of design and more innovative design. So something which is more designed for their function, we would say. So I've been kind of supporting our Thai colleagues in the design of those components.
In Sheffield, that I learned how to operate the machine in AM for AM design, the additive manufacturing design, how you make the machine is working, how to fix the model. And in UKATC, I learned a lot of the console, and finally that we learn a lot on how to, in conventional manufacturing, how to finish the surface of the miller.
Meeting P and Somo has been great. They're very willing to learn. They're very engaging with everything we do, and it's been a good experience.
Yeah, I think the knowledge transfer program is very important to both Durham and Thailand in swapping experiences on machining sides and design, and helping each other take the technology further forward.
I feel that the knowledge transfer program encourages innovation and drives forward technological advances. It's great to have like-minded people working in similar fields, contribute together to solve problems.